Have you ever boarded a plane, settled into your seat by the window, and noticed that the window doesn't quite line up with your eye level? You lean forward, twist slightly, and think, was this just bad design? Did someone forget to count the seats? And while you're at it, why are aircraft windows round? Not square, like a house window. Not rectangular, like a train window. The oval shape looks sleek, but is that really worth sacrificing a wider view? The answer to both questions traces back to one of the most catastrophic aviation disasters in history, and after it, the entire industry was never the same. Today, we're going to find out why the shape of an aircraft window is not a matter of style, it's a matter of survival. How a disaster in the 1950s permanently changed the construction of every passenger jet on the planet. And why what looks like a design detail is actually one of the smartest engineering decisions in aviation history. Let's go back to the early 1950s. Aviation was in the middle of a revolution. The British company de Havilland had just introduced the Comet, the world's first commercial jet airliner. It was a machine from the future. It flew twice as fast as propeller aircraft and climbed to altitudes where the air was smooth and stable. Passengers were thrilled. Airlines queued up with orders. But in 1954, something inexplicable happened. Two Comet aircraft broke apart in midair at cruising altitude. Without warning, without a distress signal, they simply vanished. Investigators conducted one of the most meticulous technical analyses in aviation history, and what they found stunned engineers around the world. The windows, more specifically, their shape. The Comet was fitted with nearly square windows with rounded corners, and it was in those corners that death was hiding. Here's what happens to an aircraft every single time it climbs to altitude. At ground level, normal atmospheric pressure. At 10,000 meters, the outside pressure drops close to zero. To keep passengers conscious, the fuselage is sealed and pressurized from the inside. The aircraft body literally expands on the way up, like a balloon, and contracts on the way down. This happens on every flight, over and over, thousands of cycles across the lifespan of an aircraft. The metal feels it. Every cycle creates microscopic cracks. This is called metal fatigue. Most points on the fuselage handle this stress just fine. The load distributes evenly. But at the corner of a rectangular opening, something different occurs. A corner is a stress concentration point. A force that would be harmless on a flat surface is multiplied many times over at a corner. A crack that would have arrested itself elsewhere tears through the fuselage like paper. That's exactly what happened to the Comet aircraft. The square corners of the windows became fracture points. After a few hundred pressurization cycles, fatigue cracks reached a critical size, and the fuselage effectively exploded from the inside out. The solution turned out to be elegant and simple: make windows oval. An ellipse has no sharp corners. The load distributes smoothly around the entire perimeter. Stress concentration disappears. From that point on, every passenger aircraft in the world has flown with oval windows, and not one of them has failed for this reason. Now, about the window not lining up with your seat, that's not a mistake either. Aircraft designers position windows based on the structural needs of the fuselage, frames, stringers, attachment points. The cabin layout, number of rows, seat pitch, varies by airline and configuration. Making both align perfectly for every possible setup is simply impossible. The window sits where structural integrity demands it. The seat sits where the airline decided to put it. Next time you settle in by an oval window, remember that modest rounded frame is the result of tragedy, meticulous investigation, and an engineering discovery that saved a countless number of lives. The best solutions are rarely visible from the outside. They simply work, quietly, invisibly, every few seconds, as the aircraft holds its altitude. If this video gave you something new to think about, hit like and share it with someone who thinks they already know everything about flying. Subscribe for more stories about what's hiding behind ordinary things every week.